Hey guys, Miss Marflack here. We're going to take a look at an example of graphing cosecant and secant using transformations A and B. So here's our first one. We're going to take a look at a cosecant graph with our amplitude of 2 and our B of 1/2. Now we're going to use the same process we used for graphing sine and cosine. We're actually going to use the sine graph, its reciprocal function here, as a guide. So hopefully you already checked out those Google slides with the notes. Listing out all of our variables like we've done together in class. A is 2, B is 1/2, C is 0, D is 0. I'm skipping some work here with the period, but that's our 2 pi over B, 2 pi over 1/2. We do that keep, change, flip. We have the 4 pi. No phase shift in this problem, and then we take that full period divided by 4 for our quarters. We're using that mid, max, and minimum line kind of as a guide here, scrolling down so you could see the Y a little bit more. And then now we're ready. We have all the important information we need. We have our period, we have our phase shift, we have our quarters, we have our Y values, and then most importantly, we're graphing a cosecant graph. So we're going to first start off by graphing that sine graph. So we're going to, we'll erase that. We're going to make our X and Y axis. So putting in that Y axis first, I'm taking a look and the phase shift is 0. So I know my whole function is going to be on the right side of that Y axis. Dropping in that minimum and that maximum. And then if you can, if you like, you can put in, the minimum and the maximum line. However, our goal is to erase anything from the sine function and just kind of use it as a guide. So if you're able to graph the sine function without putting these lines in, that'll be actually even better because then you won't have to erase them later. Starting at our phase shift, which is 0, adding our quarter, adding another quarter, adding another quarter. And then you see here we have that full distance from our very first point at 0 to our last point at 4 pi is our period. Now, it's a cosecant graph, which means it's reciprocal of sine. So there I am starting at the mid, going up to the max, back to the mid, to the minimum, and then back to the mid again. And it is positive, so we're graphing that positive sine function. Some people like to do this in a dotted line. I did it in a solid line. And then here's the important part. Keeping in mind that our cosecant graph is a reciprocal of our sine graph, then anywhere where sine is equal to 0, cosecant will be undefined. So hopefully you checked out those notes from the PowerPoint. And then we're going to just use the parent function as a guide, and we have these parabolas that sit on top of our humps and valleys. Now, if you want to get more exact, you could, take pi over 2 or 3 pi over 2 and plug it into the function, and you're going to see that those points kind of match up there with that parabola. Once you're done, everything that's in yellow was just used as a guide to graph cosecant. We're really interested in that red part. So I'm going to do my best on my end with the iPad to kind of erase anything done in yellow, and then there's my final answer. All right, so we did a cosecant graph, and then you guessed it, and now we're going to do a secant graph. We're going to stick with the positive, but if it did have a negative in front, it'd be the same thing, except your reciprocal function, you'd make negative. So, not cosine, we're going to do a secant graph. And we're still going to be sticking with A and B, and then in your next lesson, you're going to take a look at transformations of C and D. All right, so here we are. We have our A is 3, our B is 2, our C is 0, and our D is 0, listing out all of those variables there. And then we're going to take our period, which is 2 pi over B, and B in this example is 2. All right, and then now we're going to take our quarters, which is that full period divided by 4, and then getting that midline, that max line, and that minimum line, okay, using those formulas from earlier, adding amplitude and subtracting amplitude. All right, and then now we have all of our important information here to graph. So we're going to draw that Y and that X axis. I'll highlight our answers kind of like I did in the last problem, everything we need, which is our period, our phase shift, our quarters, our mid, max, and minimum line, and then most importantly, we're graphing a secant graph. So we're going to first get started here by putting in our Y values, and you can either put increments of 1 or you could just drop in a dash there and start straight at the 3. And then I'm going to put in that -3, and just like the last problem, you can put in those min, mid, and max lines. However, the less you kind of put here, the less you have to erase at the end. But I'll drop them in for us. And then now we're going to put those x values starting at our phase shift, which is just 0. And then now our quarter is pi over 4. So we're going to add pi over 4, add pi over 4, add another pi over 4, and then our last one, there's that full period from 0 to pi. Okay, so now it's a secant graph, which means I'm going to be graphing a cosine function. And cosine starts up at the max, down to the mid, minimum, mid, and then up at the max again. And then now, just like the last problem, okay, we're going to be putting in those vertical asymptotes wherever our graph kind of hits that x-axis. Now, that's going to shift in future problems. It's always going to be our midline, but we're really looking at what values make our function undefined. And wherever cosine is equal to 0, secant will be undefined. And then we're using the shape of the parent function, which has the humps and valleys. We have our parabolas sitting up and down from there. Like I said, you can get a little more exact if you want by picking, kind of smaller values. You could do some pi over 8, pi over 16, and you'll start to see those parabolas fill in there. And then now that you're, you're pretty much done with the graphing, we're going to try to erase as much as we can, getting rid of anything that's yellow was just used as a guide, and then there we are, we're going to leave our parabolas. If you'd like, you can put some vertical asymptotes off to the ends on the other side of the parabolas, but we'll just leave it like that. All right, do your homework and make sure you submit it to me.